You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Waste detection is the practice of identifying non-value-adding activities that consume time, attention, and resources without moving work closer to meaningful outcomes. In delivery systems, waste often hides in plain sight, waiting for approvals, excessive meetings, duplicate work, or items completed but left unreleased. The orientation here stresses that detecting waste requires discipline, not blame. Teams must apply lean-inspired metrics, simple visualization tools, and feedback loops that convert anecdotes into patterns. Waste cannot be eliminated entirely, but it can be reduced systematically when evidence is used to guide change. By treating waste as a signal rather than a shameful failure, organizations create a culture where everyone can raise concerns. The benefit is not just faster flow, but also higher morale, as teams see their energy redirected from busy work into activities that create real value for customers, stakeholders, and the organization as a whole. Waste categories provide a language for making the invisible visible. Lean thinking, originally rooted in manufacturing, describes wastes like waiting, overproduction, and defects. Adapted to knowledge work, these categories also include overprocessing, excessive handoffs, motion in the form of context switching, and unused talent. For example, a developer working on 5 items at once is experiencing context switch waste, while testers repeating manual checks because automation is unreliable are experiencing overprocessing. Unused talent emerges when people closest to the work lack voice in improvements. These categories help teams recognize that delays are not inevitable, but manifestations of specific types of waste. By naming them, teams can measure, discuss, and design interventions. Waste categories transform frustration into focus, enabling organizations to address causes directly rather than assuming inefficiency is a matter of working harder or longer hours. Signal selection is the next step, where each waste type is linked to observable indicators. Rather than relying on intuition, teams map waiting waste to age in-stage data, rework waste to return to stage counts, and handoff waste to the number of approval hops. Overproduction might be detected by measuring how much finished work sits idle awaiting integration or release. Context switching can be tracked by monitoring concurrent items per person or by sampling interruptions. Even meetings can be measured by frequency, duration, and decision yield. By connecting waste categories to concrete signals, detection becomes systematic. This mapping allows teams to collect consistent evidence, compare trends over time, and avoid subjective debates about whether waste feels present. Signal selection transforms waste detection from opinion into observation, building the credibility needed to guide meaningful change. Baselines and thresholds anchor waste detection in reality. A baseline records current levels of waste, while thresholds establish what tolerances are acceptable before action is triggered. For example, a baseline might show that stories spend an average of 10 days waiting in testing queues, and a threshold may define that more than 20% of stories aging beyond 15 days is unacceptable. Baselines prevent improvement efforts from being based on vague dissatisfaction, while thresholds prevent overreaction to normal variation. They provide evidence that waste is measurable, and they create targets that are proportional. Without baselines, teams may exaggerate issues or overlook silent drags. With them, waste detection becomes credible, aligning improvement with actual performance rather than perception. Baselines and thresholds keep focus grounded, ensuring that teams measure progress against reality, not aspiration or anecdote. Aging charts and percentiles highlight where items are stuck beyond expected windows. Instead of reporting only averages, which can hide extremes, percentiles show how work distributes across time. For example, an aging chart may reveal that while most items move through testing within 5 days, a few linger for 30, skewing overall performance. These long tails often represent significant sources of waste, as they block flow and consume attention through repeated status checks. Percentiles separate normal variation from true delay, helping teams focus on exceptional cases rather than chasing noise. Aging charts also make bottlenecks visible at a glance, prompting conversations about capacity, policies, or dependencies. By visualizing waiting in this way, teams reduce the invisibility of stalled work. Aging metrics expose the reality that flow is not uniform, and that exceptional delays often drive dissatisfaction and unpredictability. Rework measurement captures how often items move backward in the flow, revealing quality and clarity issues that inflate costs. Every return to a prior stage, whether from failed tests, unclear requirements, or broken integrations, consumes capacity that could have been applied to new work. For example, if 20% of stories return from testing to development, rework becomes a quantifiable source of waste. Measuring rework prevents it from being dismissed as normal. It also distinguishes between healthy iteration, where feedback improves outcomes, and unhealthy churn, where preventable defects dominate. By quantifying returns to stage, teams can investigate root causes, such as vague acceptance criteria or inadequate tooling. Rework measurement reframes quality debt as a flow issue, making it part of system health rather than a technical afterthought. This visibility enables targeted fixes that reduce rework and free capacity for value-adding activities. Flow efficiency provides a holistic perspective by comparing value-adding time against total elapsed time. In many streams, active work occupies only a small fraction of lead time, with waits dominating the rest. For example, a feature that takes 40 days from request to release may involve only 10 days of active work, yielding flow efficiency of 25%. Calculating this ratio highlights how much time is lost to queues, approvals, or coordination. Flow efficiency is not about pushing individuals to work faster, but about reducing systemic delays. It also provides a powerful communication tool for stakeholders, showing where improvement focus should lie. By surfacing the imbalance between effort and outcome, flow efficiency demonstrates that the greatest gains come not from working harder, but from addressing waiting waste. It frames improvement as a matter of system design rather than individual productivity. Context switch metrics capture the hidden drag of multitasking and interruptions. In knowledge work, productivity declines sharply when individuals juggle multiple items simultaneously. Measuring the number of concurrent items per person or tracking the frequency of interrupts reveals how much energy is lost to task switching. For example, a developer managing 5 parallel tickets may spend more time reacquainting themselves with context than advancing any one item. Sampling interruptions, such as chat pings or unplanned meetings, provides additional insight. These metrics expose waste that is rarely acknowledged but deeply felt. They also provide justification for policies like work-in-progress limits, which reduce context switching by design. By quantifying distraction, context switch metrics turn a personal frustration into a systemic improvement target. They reinforce that focus is a scarce resource, and protecting it is key to improving both flow and quality. Handoff inventory measures the number of transitions and approval hops that items undergo, each of which adds weighting and increases the chance of translation errors. For example, a feature that requires 5 separate sign-offs from different groups may sit idle for weeks, with each handoff introducing delay. By tallying these transitions, teams reveal where complexity accumulates. Handoff counts also highlight opportunities to collapse steps through cross-skilling, pairing, or empowered decision-making. High inventories often correlate with low first-pass yield, as misunderstandings create rework. Mapping handoffs shows where authority can be clarified and where teams can integrate responsibilities. This metric reminds organizations that waste is not always about speed but about fragmentation. Reducing unnecessary handoffs preserves knowledge, accelerates flow, and strengthens accountability. It turns transitions from bottlenecks into smoother continuities of work. Overproduction detectors identify when finished work piles up awaiting integration or release. In knowledge work, overproduction often manifests as features coded but not deployed, documents written but not used, or reports generated but never read. These represent wasted effort and create risk, as unreleased work grows stale and requires revalidation. By tracking items that are done but not in use, teams expose mismatches between upstream capacity and downstream readiness. For example, if development produces 10 features but operations can release only 5 per cycle, queues of finished work accumulate. Detecting overproduction shifts focus to aligning flow across the system. It reminds organizations that value is realized only when outcomes are delivered, not when outputs are completed. Overproduction metrics ensure that energy is synchronized with actual ability to release and absorb results. Meeting telemetry evaluates the coordination overhead of gatherings by sampling frequency, duration, and decision yield. A meeting that consumes an hour of 10 people's time but produces no decisions is a form of waste. By tracking how often meetings occur, how long they last, and whether outcomes are recorded, organizations quantify whether time is being used productively. For example, telemetry may reveal that daily status meetings consume significant hours without changing work decisions, suggesting replacement with written updates. Meeting metrics provide evidence for experiments such as decision-focused agendas or asynchronous collaboration. They also protect morale, as participants see that their time is respected and optimized. By treating meetings as part of the value stream, organizations stop assuming they are neutral and start evaluating their impact. Telemetry ensures that coordination supports flow rather than draining capacity without outcome. Tooling friction logs capture failures in automation, fragile tests, and manual steps that create avoidable pauses. For example, if builds fail unpredictably or pipelines require frequent retries, waste accumulates as teams wait or repeat work. Logging these incidents quantifies how much time is lost to unreliable infrastructure. Tooling metrics highlight opportunities for targeted investment, stabilizing tests, integrating tools, or automating repetitive steps. They also reduce frustration by validating frontline complaints with data. Tooling friction reminds leaders that flow is not only about people, but also about the systems they rely on. By addressing these gaps, organizations increase reliability and reduce context switching. Friction logs ensure that waste detection extends into the technical environment, capturing delays that are invisible in traditional project metrics but painfully obvious in daily work. Feedback intake provides a channel for frontline workers to report waste sightings through low-friction forms or tags. These sightings may capture issues that metrics miss, such as recurring meetings with unclear purpose or cumbersome approval processes. By tagging reports into categories, organizations turn anecdotes into structured data for pattern recognition. For example, multiple reports of delays in vendor responses may highlight an emerging bottleneck before metrics confirm it. Feedback intake democratizes waste detection, empowering all contributors to shape improvement. It also reinforces psychological safety by showing that raising inefficiencies is encouraged, not punished. By blending formal metrics with human reports, organizations capture a fuller picture of waste. Intake systems create a loop where frustration feeds evidence, and evidence drives change, ensuring that waste detection remains grounded in lived experience as well as numbers. Non-functional blind spots often hide waste in security, performance, and operability work deferred until late in the cycle. For example, if performance testing is postponed until final stages, defects discovered then create costly rework. Mapping these blind spots surfaces where non-functional obligations are treated as afterthoughts rather than integral parts of flow. Detecting them early enables tasks to be integrated into the value stream, reducing high-cost waste later. These scans remind organizations that value is not only feature delivery, but also safe, reliable, and sustainable systems. Non-functional blind spots are a subtle form of waste, as deferred obligations eventually manifest as expensive delays, firefighting, or compliance penalties. By addressing them proactively, teams reduce hidden costs and strengthen trust. Waste detection thus becomes not just about speed but also about protecting long-term quality and resilience. Anti-pattern awareness protects waste detection from losing credibility. Common pitfalls include metric theater, where dashboards are created but not acted upon, focusing only on easy-to-measure wastes while ignoring more complex ones like unused talent, and blaming individuals rather than addressing system design. These traps reduce trust and make waste detection feel punitive rather than constructive. By naming anti-patterns, organizations remain vigilant against distortions. For example, if context-switch waste is attributed to worker discipline rather than overloaded systems, the wrong problem is solved. Anti-pattern vigilance ensures that detection stays focused on systemic causes and practical improvements. It reminds teams that the purpose of waste detection is learning, not punishment. By avoiding these pitfalls, waste detection retains its integrity as a tool for resilience, efficiency, and morale, rather than a source of fear or cynicism. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Detection cadence establishes the rhythm by which waste signals are observed and acted upon. Without a routine, monitoring becomes either sporadic or overwhelming. Weekly scans of common signals, such as aging, rework, and work in progress, provide frequent feedback, while deeper monthly reviews tackle broader issues like handoff complexity or meeting load. This layered cadence balances responsiveness with sustainability. For example, if items are aging beyond thresholds, the weekly scan surfaces them quickly, while a monthly review may reveal structural causes like overloaded approval steps. Cadence also builds trust, as stakeholders know when issues will be raised and when they will be revisited. By embedding waste detection into predictable intervals, organizations ensure that vigilance is consistent, not ad hoc. This rhythm prevents both fatigue from constant monitoring and complacency from neglect, sustaining waste detection as a practical, balanced habit. Visualization practices make waste signals tangible by displaying them directly on workboards and dashboards. Instead of hiding metrics in reports, teams place aging badges, return counters, and WIP limits where they are visible during planning and daily stand-ups. For example, a card might carry a red indicator if it has been in testing beyond its expected window, prompting immediate discussion. Visualization turns abstract data into actionable prompts that influence behavior in real time. It also democratizes detection, enabling everyone to see the same signals and contribute to problem solving. By making waste visible, teams shift improvement from occasional projects to continuous practice. Visualization reinforces that metrics are not for inspection by managers alone, but tools for shared accountability. It transforms waste detection from background analysis into a live, collaborative activity woven into daily work. Root cause sampling provides depth to waste detection by pairing observed signals with brief analyses that distinguish symptoms from causes. For example, a recurring delay in approvals may appear as waiting waste, but a sample root cause review might reveal unclear authority or inconsistent criteria. These short inquiries prevent overreaction to surface-level data. They also make waste detection more actionable by uncovering leverage points for change. Root cause sampling need not be exhaustive. Small, targeted analyses often suffice to identify practical interventions. By connecting metrics with underlying drivers, organizations avoid superficial fixes that treat the symptom but leave conditions unchanged. Sampling demonstrates that waste detection is not just counting inefficiencies but understanding why they occur. This practice keeps improvements proportional, ensuring that resources are directed to real system weaknesses rather than cosmetic adjustments. An experiment backlog converts detection findings into small, testable changes. Instead of attempting massive overhauls, teams propose lightweight trials with explicit success signals. For example, if meeting telemetry shows low decision yield, the backlog might include a trial of written updates for status sharing, measured by reduced meeting duration. Each experiment is framed with a hypothesis: what waste will decline, how it will be measured, and within what time frame. By treating improvements as experiments, organizations reduce fear of failure and encourage learning. The backlog also provides visibility, preventing detection insights from languishing unaddressed. Prioritization ensures that the most promising or urgent experiments are tried first. This approach makes waste reduction iterative and cumulative. Small, validated wins build momentum, proving that incremental experiments can deliver real impact without disrupting flow or overwhelming capacity. WIP limit trials provide one of the most direct ways to test whether reducing concurrent work decreases waste. By capping the number of items allowed in a stage or per person, teams observe whether flow stabilizes and rework declines. For example, limiting developers to 2 active stories at once may reveal sharper focus, shorter aging times, and fewer returns. WIP trials are often resisted at first, as they appear to reduce productivity by restricting starts. However, evidence usually shows that limiting work in progress accelerates finishes and reduces context switching. By treating limits as trials rather than mandates, teams build trust and gather data on impact. Successful trials often lead to permanent adoption, supported by evidence. WIP limit experiments demonstrate how structural adjustments can reduce waste by design rather than by exhortation, embedding focus into the system itself. Handoff minimization tackles waste at one of its most persistent sources: excessive transitions. Techniques such as pairing, mobbing, or cross-skilling allow work to stay with fewer people until it is complete, reducing idle time and translation errors. For example, a developer and tester working together may eliminate multiple back-and-forth cycles, improving first-pass yield. Cross-skilling enables teams to absorb work directly without waiting for specialists, while mobbing creates shared understanding across roles. These practices do not eliminate handoffs entirely, but reduce unnecessary fragmentation. Handoff minimization transforms collaboration from sequential to concurrent, smoothing flow and reducing rework. It also strengthens team cohesion as participants gain appreciation of each other's perspectives. By minimizing translation steps, organizations reduce one of the most costly and frustrating forms of waste, accelerating outcomes and improving quality simultaneously. Decision latency reduction targets the idle time that accumulates when approvals or clarifications stall progress. Teams shorten this waste by introducing pre-reads, decision packets, and clearer decision rights. For example, a packet summarizing options, risks, and recommendations allows decision-makers to review asynchronously, making meetings more efficient. Clear authority definitions prevent items from languishing in limbo while stakeholders debate ownership. Decision latency is often underestimated, but it can consume large portions of lead time. By reducing it, organizations accelerate flow without increasing workload. Improvements also raise morale, as teams no longer feel trapped by invisible bottlenecks. Decision latency reduction reframes governance from a blocker into a streamlined enabler. It shows that accountability and speed are not opposing forces, but can coexist when decision processes are designed thoughtfully. Automation and golden path investments address recurring manual steps that consistently stall flow. Golden paths are standardized, automated workflows that reduce variation and friction. For example, an automated pipeline for testing and deployment replaces manual scripts, ensuring consistency and speed. Investing in these paths prevents repetitive stalls, such as flaky builds or failed handoffs between environments. Automation does not mean removing human judgment, but focusing it where it adds unique value. By reducing waste in repetitive steps, organizations free energy for creative problem-solving. Golden paths also reduce risk by embedding proven practices into standard tools. This approach transforms waste detection into long-term resilience, as identified inefficiencies lead to durable automation. Automation investments ensure that waste reduction scales sustainably, preventing the same obstacles from recurring across cycles. Meeting hygiene experiments test ways to improve coordination efficiency. Common approaches include replacing status meetings with written updates, enforcing decision-focused agendas, and limiting duration. For example, Shifting daily check-ins to asynchronous updates may reclaim significant time without harming alignment. Hygiene trials measure impact by tracking decision yield per minute or total meeting load. These experiments challenge the assumption that meetings are unavoidable, reframing them as processes subject to improvement like any other. Meeting hygiene improves morale by respecting participants' time and reinforcing that collaboration should add value. By running small trials and measuring results, organizations build evidence for broader adoption. Hygiene experiments demonstrate that even deeply entrenched habits can be optimized when waste is measured and addressed systematically. Vendor interface checks extend waste detection across organizational boundaries. Delays and rework often originate from fragile integrations, unclear contracts, or mismatched expectations with external partners. By introducing contract tests and shared dashboards, teams monitor interfaces proactively. For example, a shared uptime dashboard with a vendor ensures that both sides see the same signals, reducing disputes and accelerating resolution. Contract tests verify compatibility before releases, preventing boundary waste from escalating into incidents. Vendor checks reinforce that waste is not only internal but also systemic. By managing interfaces actively, organizations reduce idle time waiting for fixes and prevent avoidable rework. These practices turn external relationships into transparent, accountable parts of the flow, embedding resilience into the entire delivery ecosystem. Ethics and compliance alignment ensures that waste reduction does not undermine safety or accountability. Efforts to cut steps or approvals must not externalize risk by eliminating necessary controls or evidence. For example, removing a compliance review may accelerate flow but create costly failures during audits. Alignment requires distinguishing between true waste and essential safeguards. By embedding compliance professionals into detection and experiment design, organizations ensure that improvements respect obligations. This practice protects credibility and prevents shortcuts that harm trust. Ethical alignment reframes waste detection as a way to optimize delivery without sacrificing responsibility. It reinforces that efficiency and accountability must advance together. By aligning with ethics and compliance, organizations ensure that waste reduction strengthens resilience instead of eroding it. Measurement of impact closes the loop by verifying whether detection led to real improvement. Metrics include lead time distributions, rework reductions, and flow efficiency gains. For example, if WIP limits were trialed, impact is confirmed by shorter aging times and fewer returns to stage. By measuring before and after, organizations separate perception from reality. This accountability sustains trust in waste detection as more than an exercise. It also prevents cosmetic changes from being celebrated without evidence. Measuring impact ensures that detection leads to tangible benefits in speed, quality, or predictability. It builds a culture where improvement is validated, not assumed. This discipline transforms waste detection into a continuous learning system, where each cycle of detection, experiment, and measurement compounds maturity and capability. Knowledge sharing spreads the benefits of waste detection across teams. By publishing before and after examples, templates, and playbooks, organizations enable others to replicate high payoff methods. For example, a team that succeeded in reducing meeting load might share its agenda template and decision packet design. Knowledge sharing accelerates adoption, preventing each team from rediscovering solutions independently. It also strengthens culture, signaling that improvement is collective. By curating successes and making them reusable, organizations turn local wins into enterprise-wide gains. Knowledge sharing ensures that waste detection is not siloed, but becomes part of the shared language of improvement. It transforms isolated experiments into institutional capability, raising maturity across the ecosystem. A sustainment plan ensures that waste detection remains credible over time. Metrics must be pruned when they lose relevance, stewards rotated to prevent fatigue, and thresholds refreshed as system behavior evolves. Without sustainment, detection decays into stale dashboards and ignored reports. For example, if an aging threshold is never updated, it may become irrelevant as the system improves, reducing trust in metrics. Rotating stewardship ensures that vigilance remains energized and diverse. Refreshing thresholds ensures that goals remain ambitious but realistic. Sustainment preserves trust and prevents complacency, ensuring that waste detection continues to provide value. It reinforces that improvement is not a one-time project but a long-term discipline. By designing for endurance, organizations keep waste detection fresh, impactful, and aligned with evolving needs. Waste detection synthesis highlights that reducing inefficiency requires more than observation. It requires targeted signals, visible artifacts, and small ethical experiments. Metrics like aging, rework, and flow efficiency reveal where waste accumulates. Visualization and feedback loops make signals live, turning them into daily prompts for action. Experiments such as WIP limits, handoff minimization, and meeting hygiene show how waste can be reduced incrementally without disruption. Vendor checks and compliance alignment extend vigilance across boundaries and protect trust. Measurement of impact and knowledge sharing ensure that wins are validated and scaled. Sustainment practices preserve relevance and credibility over time. Together, these elements transform waste detection into a practical system that reduces delay, rework, and drag while safeguarding accountability. Waste detection, done well, creates faster, safer, and more satisfying delivery by aligning energy with value and trimming what does not serve. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.